Ever walked out of a store and suddenly heard that loud alarm from the anti-theft gates? The weird part is, the tag does not even need to be visible. It can be hidden inside packaging, stuck under a label, or attached to clothing, and somehow those gates still know it is there. So how do store anti-theft gates actually detect hidden tags? Today on Knowledge Hub, we are going inside the technology behind those security gates, and the secret is not cameras, lasers, or someone watching you from a screen. Most stores use a system called EAS, which stands for Electronic Article Surveillance. The idea is simple. A small security tag or label is attached to an item, and the gates near the exit create an invisible detection zone. When an active tag passes through that zone, it reacts to the signal from the gates. The gate detects that reaction, confirms the tag is still active, and then triggers the alarm. One of the most common types is called RF, or radio frequency security. These are usually the flat sticker-style labels you might see on boxes, cosmetics, books, or small electronics. Inside that sticker is a tiny circuit made from a coil and a capacitor. This circuit is designed to respond to a specific radio frequency. So when the store gate sends out a radio signal, the active tag resonates, almost like a tuning fork reacting to the right note. The gate is constantly listening for that exact response. If it hears it, the alarm goes off. That is why the tag can be hidden. The gate is not trying to visually find the sticker. It is detecting the electromagnetic signal coming from it. Another common system is called AM, or acoustomagnetic security. This is often used in clothing stores and supermarkets, especially with hard plastic tags. Inside these tags are thin strips of special magnetic metal. When the gate sends magnetic pulses, those strips vibrate at a very specific frequency. After each pulse, the tag keeps vibrating for a tiny moment, almost like a bell ringing after being hit. The gate listens for that signal pattern, and if it matches, the system knows an active tag is passing through. There is also M, or electromagnetic security, which is commonly used in libraries and some retail stores. These tags can be very thin magnetic strips, which makes them useful for books and small items. They can also be activated and deactivated repeatedly, which is perfect for items that are borrowed, returned, and borrowed again. But what happens when you pay for the item? At checkout, the tag is either removed or deactivated. A hard tag is physically removed using a special detagger. A soft label is deactivated by changing its electrical or magnetic behavior, so it no longer responds correctly to the gate. So the gate is not asking, "Is there a product here?" It is asking, "Is there still an active security tag inside my detection field?" Some modern stores also use RFID, which stands for radio frequency identification. RFID is more advanced because instead of only detecting that a tag exists, it can store digital information about the item. That means the system may know exactly which product is passing through, not just that there is an active tag. This is useful not only for theft prevention, but also for inventory tracking, stock counting, and supply chain management. Of course, these systems are not perfect. Metal, liquids, poor tag placement, nearby electronics, and even how fast someone walks through the gate can affect detection. That is why stores use different tag types for different products and carefully tune the sensitivity of their gates. So next time you walk through those store anti-theft gates, remember, they are not seeing through your tag, and they are not scanning you like an airport machine. They are creating an invisible electromagnetic zone and waiting for a hidden tag to answer back. And when that tiny tag gives the right signal, the gate instantly knows something is still active. If you have enjoyed this video, make sure to subscribe to Knowledge Hub for more everyday technology explained simply. And as always, stay curious.